The code that we have is a liability, and the system is the asset that we're building. Phoenix architecture takes this same exact idea, but it says ideally what you should have is some sort of a specification for the system, and then the code you should think about as just an implementation detail or a build artifact. And the reason it's called Phoenix architecture is like the metaphor of the phoenix that's destroyed and rebuilt and rises from the ashes. But the entire architecture is about constantly replacing every piece of the system, but not replacing the system as a whole. The goal here is to be able to deploy code in production that was generated by AI of some sort that humans never reviewed. We know that's what's going to happen because we know human behavior, and it's way too easy to do that now. So people are always going to do the easy thing. So let's figure out systems that make the easy thing okay to do.
You have a statement that said evaluations are the real code base. How do you think about durability? What is it that as I build IP or as I build up anything persists across?
That's a good question.
Back in November, we hosted the first ever in-person AI Native DevCon in New York. This June 1st and 2nd, we're bringing it to London. It's 2 days built for AI native developers and engineering teams. 1 day full of hands-on workshops and 1 day full of practical talks on agent skills, context engineering, agent orchestration and enablement platforms, and how teams are actually shipping AI in production. Join us at the brewery in London near the Barbican for all of that, plus networking, parties, giveaways, and a room full of people building the future of AI native development. You can also join us from anywhere in the world via the live stream. As you're listening to this podcast, you get 30% off your ticket with code POD30. Just head to ainativedevcon.io and we'll see you in London.
Hello, everyone. Thanks for tuning back into the AI Native Dev. Today, we are going to go, I don't know if it's far into the future, but definitely looking into the future or the concepts of it with Chad Fowler, who is a VC today, but don't hold it against him. He's today at Blue Yard Capital, but he really has this sort of rich technical background on it. Some of you might know him as the person leading Ruby Central at the time when Ruby was all the rage, what feels like a while ago. But very innovative. I think you were CTO at Wunderkinder. Not sure
That's
how to
right.
call that, which you sold to Microsoft. And you were CTO for a variety of departments or sort of areas for Microsoft then. And generally, I think a fairly well-known thought leader in the space. And specifically, for this podcast, what pulled you in is that you've been writing some really interesting blog posts and like little storylines and perspectives on the future of software development and where that is headed in the Phoenix architecture blog, which is inconveniently posted on aicoding.leaflet.pub. Every time I have to find that, but it really good blog, really good ideas, which we will talk about today. So Chad, thanks for coming onto the show here and sharing some perspectives.
Yeah, thanks for having me. It's a totally exciting time to be talking about software development. So I want to do as much of it as I can.
Yeah, I fully agree with it. Like unsettling, interesting, cerebral, fast-moving, a lot of this excitement, and never boring. Super interesting.
Yeah.
So I guess we're going to talk a lot about the Phoenix architecture, and I want to maybe dedicate some specific focus on what you mean by this. But maybe for starters, I know there was a bit of a origin for all of these things, thinking, and you were sort of thinking about code as disposable and these types of views for a while now. So can I, for starters, just have you tell us a little bit the origin story of how did you come to this line of thinking and
Sure.
how that came about?
Yeah, I guess, it started with in the early 2000s. Somehow I ended up in this line of consulting and full-time jobs where my job was to euthanize an existing software system. So come find some system that's doing good work, but can't keep up with the demands, like the technical demands or the business demands posed to it. And so I'd come along and kill the systems. And I started getting really tired of that because I was thinking about what about my own systems that I create? Think about how much time and effort and emotion I put into my work. How can we build systems that can outlive us? Why are we building all these systems that are dying within 5 years? It's insane. And so I started thinking a lot about legacy and what that word means, and also just like biological metaphors for software development, because I thought, well, I don't take very great care of myself as a human, but I'm still here. How is that possible? We spend all this money on software systems, and they still sort of get corrupted and die
Yeah.
and fail under their own weight. And so a couple of sort of key insights came to me, one of which I didn't really act on much over the years. The first one is just about infrastructure. And I started thinking about, how we, in the like 90s, we would be excited about uptime for a given server. We install these massive big Sun servers or whatever. And I remember one that had been up for like 2 years without being rebooted. Terrifying, but back then we were proud of it.
Yeah.
And I realized that, like, if you want to be able to change things, you need to do it all the time. And so, this sort of behavior, whether it be in infrastructure or software, would lead to situations where you just couldn't progress the system because you're not practicing change. So the first insight that I had in this sort of legacy thing is, let's just kill things over and over and over so that we
Right.
can be used to killing. And I started with infrastructure. And now it's just like old hat, the idea of immutable infrastructure, but like never ever modify a server, always replace it, which of course you couldn't do with physical hardware, but you can do with
Right.
containers and, EC2 instances is what we were doing back then.
Right. But not just even for the purpose of kind of learning and the agility, but also to know that you can do it, to really truly know that you're able to recover from a server failure, is to do it all the time intentionally.
Right. And why is that? Why is that the rule? It's because if you cannot change the system, it means you don't actually understand the system.
Mm-hmm.
So, if you're changing it constantly, you understand what the requirements are. Just you have to, right? So the same should be true in software, but it was much more expensive, 15 years ago or so, to just throw away code all the time. But I was thinking a lot about, like, what would it mean to have disposable software, immutable code? So as soon as you write like one unit of work, whatever that is, you never modify it again. You just throw it away because the unit of code itself is small enough and like bounded enough that you can understand what it's supposed to do trivially, and therefore you can safely replace it. So this is the sort of backstory that when you pit it against where we are in terms of like LLM generated code, it starts to click, and you say, oh, okay. And we can go into that in more detail later, but that's sort of the origin story of this thinking.
No, I love that. And I love the analogy to immutable infrastructure, because I think so many DevOps analogies are helpful, at least to me or to people that have kind of been through the DevOps change, to be able to kind of apply those to AI and try and forecast where it's headed. The fact that servers are statistical creatures, right? And they don't always behave the way we want them. And so we need to deal with a world in which it's not deterministic, and to move those. So I love the immutable software or rather immutable infrastructure concept, and applying that to immutable software. And think, okay, what have we learned about immutable infrastructure that we need to now kind of represent here?
Right. Yeah, there's also, like, as you were talking, I was thinking, there's also this thing back in the day, like when I talked about how proud I was of my 2-year uptime on a server, I also knew that server's name, and I knew its IP address, and I like set it up myself physically. I cared about it. You know what I mean?
Yeah.
And so I was like attached to this thing. And when you get to immutable infrastructure, you can never be attached to like one running instance of your software stack. I think the same sort of lesson applies to code too.
Yeah.
That we have all developed, especially developers, this almost fetish-like worship of our code, forgetting that the code is not actually the thing we're trying to build. It's just the implementation of the thing we're trying to build.
Yeah, no, I love that. That's in DevOps is the whole ethos of cattle versus pets, right? You have the ones that you're nurturing as pets, which is what you're describing, and it is a really interesting thought to say, how do you think of code as cattle, and you just have plenty of it and you keep swapping it, which was just not feasible before. Just like immutable infrastructure was not really feasible or practical, I guess, except for very unique circumstances before the cloud enabled it.
Yeah. So, I mean, how would you make it feasible? Even back then, as I said, I was like starting to think about this. The first rule when I was working on Wunderlist was, you can do code in any language you want, as long as it's no more than this big. And so, it literally say this. So it just means
gesturing for a small amount, just between
roughly like it fits on a page. of your editor. So if you have really good eyes, you can have you can have more code because the font can be smaller. But we actually did this, and we did this sort of like radical microservices architecture. And there were at least a couple of cases where code was disposable because of this. We had like consistent calling conventions, and sort of just, we had like a way of dealing with mutations offline, and we had a way of dealing with REST and CRUD sort of stuff through the system. And it was all consistent. And all the code was tiny, which meant we were able to replace things. So the two versions of this, one, I had written a service in Haskell, and I was one of only two people who would tolerate even looking at Haskell. I loved it. And it did a great job.
Write-only code.
Yeah, yeah. And in fact, in this case, that was the problem. So we had to change this code so infrequently that the build system became stale underneath it. And after we were acquired, we could not recompile the code anymore. It still worked. It was great, but the tool chain had broken underneath us because we didn't have that rigor of constantly changing it. So there was a problem with it at one point, and someone just said, well, we're just going to rewrite this in Go or something. So they rewrote it in like an afternoon and deployed it. It was fine, Yeah. And the other thing was we had deployed a major release of Wunderlist, which was like the, sort of crown achievement of what we did technically. And when we did it, we had literally hundreds of server instances running these heavy Ruby on Rails servers, because that's what we knew. It was like the consistent choice. But then afterward, over the course of like 3 months, we replaced something like 70% of the code base with Clojure, Go, Rust, etc., and made it, like, I don't know, I think it cost like 25% of what it did at launch to run, because we were able to replace all these systems that were running Ruby, because they were all just tiny little things with consistent calling conventions and easy to plug in. That was our first attempts at doing this sort of disposable code thing.
Yeah, no, and I love that. And I think some of the kind of clear modularity goes all the way back to sort of Java design partner design patterns, just thinking about, abstract, factories of factories, and kind of a creation of those that, at least from a dynamism of the software and the ability to hot load different components, will come in. And I guess we still think of the code itself oftentimes as the thing that is precious, even if we modularized it within the system. And I guess, this is AI land or AI era now, and so clearly that is now changing. So maybe tell us a little bit about the Phoenix architecture. I love in general a lot of the storytelling you have on the blog, but some of these visual analogies are helpful and fun. So you talk about Phoenix architecture, you talk about regenerative software. So you've already alluded to some of it, but tell us a bit about what's the philosophy behind that.
Sure, yeah. So, if you think about what I was just saying about consistent calling conventions and generally conventions for like what the interfaces would be, how you think about CRUD operations on data. And this doesn't just apply, of course, to CRUD-based REST apps, but these are all ways of constraining a system so that you understand how the components interact with each other, so that the components could then be potentially implemented in any language or framework or whatever. You still have the idea of how the system works. And one thing I used to always say to the team at Wunderlist is the code that we have is a liability, and the system is the asset that we're building. And the Phoenix architecture takes this and sort of codifies it. And I also have a not yet released, but eventually open source project called Phoenix, which is like the actual implementation of all this stuff I'm talking about. But it codifies it, and it says, any software in the system you should think about like it's a build artifact. So, imagine you have a make file or and file or whatever the dependency-oriented build system thing is, there's always some sort of top-level asset that you start with. Usually it's code in a high-level language, and you run a thing, and it understands the path, and it can compile all the way through. It can invalidate any object code that's changed, if you're talking about like a truly compiled system or a VM type system like JVM. And it can replace just the paths that need to be changed. But the top-level like asset that you're building in that case is the Java code or the C code or the Rust code. The Phoenix architecture takes this same exact idea, but it says ideally what you should have is some sort of a specification for the system. And then the code you should think about as just an implementation detail or a build artifact. And the reason it's called Phoenix architecture is that, these, like the metaphor of the phoenix that's destroyed and rebuilt and, rises from
Right.
the ashes. But the entire architecture is about constantly replacing every piece of the system, but not replacing the system as a whole, because you need that sort of consistent shape and calling convention for interacting with the system, generatively. And so, yeah, that's sort of the key thing of if if we want to be able to change systems safely and rapidly, and we want that to be how we interact with our systems, they're just like very change friendly, then like I take a lesson actually from extreme programming, Kent Beck, all those people in the early agile days. If something's hard, just do it all the time. So if testing is hard, then do it all the time. If code review is hard or expensive, then just do it all the time by doing pair programming. The idea here is if change is hard, then just build it into the system so you have no choice but to constantly change. And you can also never actually look at the code. And I guess I should sort of back up and say the goal here is to be able to deploy code in production that was generated by AI of some sort that humans never reviewed. And this would have sounded more crazy 6 months ago. Now, a lot of people are doing this, but at scale in like big enterprise systems or very complex older systems, of course, you can't do this yet, So if that is the goal, and why would that be the goal? Because that's what's going to happen. We know that's what's going to happen, not because like we're looking at the future and we're looking at technology trends, but because we know human behavior and it's way too easy to do that now. So people are always going to do the easy thing. So let's figure out systems that make the easy thing okay to do.
Yeah, I think it's also the opportunity. It's not just that it will happen. It's also the means of staying competitive is to be able to tap into that and to take the human out of the equation. But so as someone has been saying, code is going to become disposable a couple of years ago, and kind of was dismissed as heresy not that long ago, like sort of 2 years ago. Today doesn't feel as far-fetched. But let me ask about a few challenges kind of within that world. So I think the most blatant one is, what is sufficient detail in the spec, and at what point does that sufficient detail just become a different piece of code that you've written, and all you've done now is like create some sort of template that's at the top? How would you define the right level of specificity in the spec, and which parts you're happy to delegate to the implementer that is the agent?
That's a good question, and the answer changes weekly, kind of, Like, I mean, since you've been talking about this for at least 2 years, it means probably 4 years ago you were messing around with code generation and in the frustration loop constantly. Like, oh my God, it's magic, and then it's not magic anymore. Fails, And I think the last time I felt that way was like September or October with the tools available, and now I don't feel that way anymore. But I know it doesn't sound like I'm answering the question, but the reason I'm saying this is there's a whole lot more you can one shot with very little detail these days. However, like forgetting about the fact that it just keeps getting smarter and smarter, I think the answer for me is that I want to iterate until I see the thing change, right? So like I'm working on a new IRC network, for example, a reboot of IRC right now. I didn't one-shot it. I've got all sorts of interesting technical things in it. It's called Freak, by the way. And when I worked on it, I didn't create a spec that had a great level of specificity, but I iterated until I had a spec that was enough. And I knew it was enough because I see the evidence in the software. So it's kind of like you go back to the early 2000s. We had this thing called naked objects in Java, where you just like generate Java objects and it creates the UI for you on the fly. And the whole idea was a new agile way of working with customers and software, where you just like pop things open and show that to them and iterate like that, sitting with the customer instead of like going on these long project things.
Right. Interact with the data model. Yeah.
Yeah, and I think it's the same sort of thing now, where you can iterate and iterate. The problem this creates, though, is if you want a system that can survive change over time, you can't just regenerate the entire thing constantly.
Yeah.
So you need to be able to iterate, but you need to have some way of being very clear about which things are changing. So like there are two issues. One, if a user knows how to use an application and it changes every day because you've changed the spec and regenerated it and reimagined an entire UI, that's not okay. Even if the UI is great, even if it's better tomorrow than it was today, users have to actually like understand how to use the software. And the other is you just don't want things that are like core to the technical foundation of your system to change constantly because they might be wrong, right? And that's where this level of specificity matters a lot, where
Right.
one intuition, like, so an example of this is I'm building this IRC network. So I've got IRC server that implements the protocol, and then I've got protocol layers on top and another layer, and then I've got clients, and client SDKs. At the very bottom level, I want to get that right quickly and just set it in stone and probably never change it unless there's a mistake or we want to upgrade the IRC protocol, right? And so the best way to do that would be if there were some set of specifications that we iterate on that we can literally tie through some like build graph back or to the code that gets generated, and it never has to change unless the dependency tree changes before it. So we can change the protocol all we want in the beginning, and then we sort of lock it because we never change even the like vague specs we created that happened to create a thing that was good enough. This
Yep.
sounds pretty scary, I know. And then you just, you work in the layer that makes sense to do a lot of change. There's a term, I can't remember the person's name who coined it, but a term called pace layers that sort of codifies this idea of different speeds of change, layers of a software
different.
architecture.
Yeah. I think so I've done a fair bit of thinking of this, and in the Tesla framework that we've since kind of parked as we focus on Tesla on context management, and we can get a little bit into the delta there. We had a lot of these elements, and we talked precisely about that, in that you will create a spec, and the spec can be at whatever level of resolution. You reach software that you bless by using it and looking at it and sort of deciding that it is good enough. And then from here, you have the question of what you want to achieve is stable regeneration. So, you when you regenerate it, you want stability. You might have a button. You might not care what color it is, and you're happy to delegate that to the agent, but you don't want to change in colors every version. And so you want some stability over there. And so you want that, and the challenge, of course, is figuring out what are the aspects that you want to stabilize, because increasingly, like those change. Like maybe you want the button to be the same color, unless it has a good reason to change, because you've just changed all of the theme's colors, and so the button should also change in that process. And we actually introduced, you used the word lock. We had in the system tests for the different parts of the spec, and you could lock a test to imply it. And so it is very interesting, and I think probably a bit of an unsolved and an interesting interaction model as well of if you were to create these different things, and let's say your information architecture allowed that, what is the sort of the user interaction that you would have with these assets. And maybe I'll throw one more, which is I think there's also an element of who made the decision that is more important. If I said something, me, the human in control, who is paying the bills and whose neck is on the line, that should be more holy than if the agent has made a decision, and that decision should be more easily overwritten because it was just making it at the time. So there's a lot to sort of figure out. I don't know if would you anticipate like new programming? This is like a frequent question, that I get as well. It's like, would you anticipate these things manifesting in new programming language paradigms, or are these just patterns that will eventually be applied by the agents?
They will manifest in programming languages, but I think that's also a step along the way to where it goes, because I think what we're going to find is, like, any programming language we create is going to be trying to solve problems that LLMs can't currently solve with plain language, and then they'll become obsolete. Like, my first assumption when I started doing stuff with ChatGPT, early ChatGPT days, was, oh, we should be using like Haskell or OWL and RSS, like ontologies. And I had all these ideas about static typing being better and blah, blah, blah. It's just all doesn't matter, actually. But I think what we need instead is different programming paradigms and patterns that aren't languages. So, my work right now on my implementation of this Phoenix architecture is focused on going from raw human specs to refined, they're called clauses in my system, where you can like canonicalize actual intents out and then you can do hash-based tracking of these intents all the way through, like cryptographic hashes, which gives you that build system thing, but it also gives you the ability to add provenance, because I absolutely agree, like capturing intents of the system and capturing who made them and like when and why are really critical, both in like knowing what to regenerate and also in just like figuring out how you would remove things from a system. That, like, to me, that's the biggest problem, because we're generating things at such speed. You're going to end up creating like absolute masses of garbage. And if the
Yeah.
agents did it and not the person, you know, it's probably okay to delete. You know, there's a lot of other factors
Yeah.
you have to check. But like on my IRC system, Freak, I actually have 2 parallel web apps by accident. I have a really nice one that I've been iterating with, and then one that the agents just decided they were going to make, and it's linked some places, so I have to remove it. But like, at least I know in this case that I made this decision. But I think what's really interesting is the combination of what we were just talking about with specs, et cetera, and then like capturing the human interaction with the LLM as the code is being built. And there's a bunch of work going on here of doing this. And to me, that's the important thing, is like, how do we figure out how to map from intent all the way through to object of code, whatever that means, implementation unit, in as clear and replaceable a unit as possible. Then we have the ability to do this regenerative software thing for real.
Yeah, throughout. I think super interesting, and I guess my thesis also would be that there are sort of 3 layers of human condoning, you know, or like blessing. There's the explicit instruction that came from the human developer. There's the explicit review. I actually read this and said yes, which is a bit tricky, because did you really read it? I don't know. You know, like, you technically it says, is this okay? Should I go? And you said yes. And then there's the, you know, no human interaction. The agents just decided those. Yeah, we had a lot of those. We, by the way, refer to them as shadow specs. There's the spec and the shadow spec, which are the decisions you never made but have been made for you.
Yeah,
in the past.
that's a good term. I like it.
Yeah.
And I must admit, most of the work that I do, I've got mostly shadow specs with like really high level stupid instructions these days. And I go, YOLO, you know. So my
Yeah.
review, my explicit review, I did not read it. I scanned through it. And I was like, yeah, that sounds right.
Exactly, just sort of
Yeah.
blessed it. Yeah, and there's kind of these 2 levels. I don't know how to sort of name them. There's sort of levels of shadow, like, you know, the shadow and the dark spec. I don't know, but you know, the ones that you in theory reviewed, and the decisions that were never presented to you, they were just made.
Yeah.
And you could have proactively gone and reviewed, but you didn't bless.
Like, asking about programming languages reminds me of a conversation I had earlier this week with a real language innovator. I won't say who it is because I didn't ask if I could, but we were talking about, specifically, as I take all these stupid ideas I have and I try to make them into real code that I can create projects with, one of the first things that I ran into was, you know, I keep saying like consistent calling conventions and ways of dealing with mutations in the system asynchronously. So there's some sort of message bus thing. Like, there's sort of these things I have in my head for what you need for a Phoenix type architecture to work. And the immediate thing that I run up against when I started generating this is, oh, I actually have to choose like what language and framework. Let's say I'm going to build a web app, like what MVC framework is it going to be in? What programming language? What runtime? And I reached the conclusion that I should just decide this for the entire system for any code that's generated. So like, we can start with web apps. I'll just decide, like, okay, what's the best framework for generated code for a web app in AI today? I think there are 2 answers to it. One is whatever the LLM knows. So probably like
Yep.
2 years old Next.js or something, you know, React. Not things I like. It makes me sort of ill to say this.
Yeah, but it's whatever it is that has this sort of the sweetheart of the weights at the moment,
Exactly.
which tends to sort of persist historical popularity.
Yes. Well, now it's really going to lock in forever because we're going to keep
Because
regenerating
everything
code
is
from these
getting
LLMs.
duplicated and it feeds itself. Yeah.
But what really matters now is, you know, like I was all into Ruby and Rails and evangelism and all this stuff back in the day, you know, as you mentioned. I would not do that today. I would not tie myself to such a thing, because what matters is the code has to be able to be correct. It has to be as cheap as possible to run. It has to perform as well as it can. It does not have to be human friendly. It doesn't have to be trendy. It doesn't even have to have unit tests. You know, you don't have to do
written in
TDD.
Haskell. You know,
Yeah.
it's okay.
So what I realized is this Phoenix architecture, like, I don't think you will decide when you use it what the like framework is or the language that it generates. You shouldn't. That should also be a thing that's completely open to change. So what we'll be compiling to is more system architectures, a shape of the system that allows us to have pluggable, replaceable components because of the shape of the system, because of the calling conventions and the consistency, and probably some sort of like type system. There will be these sort of properties, but they won't be about the programming language. They'll be about how this thing runs and how the components interact.
Yeah. I think so that's a good kind of tee up for a challenge that I have in my mind. So clearly I've been on the sort of the spec-centric software bandwagon for a while, like literally have been sort of devoting kind of my time in Tessel to pursuing this vision. And like probably the most significant way in which I feel like my thinking has yeah, I want to say evolved or at least changed, maybe it's regressed over time, is the move from more of thinking about a spec and some data format definition in which you properly capture your intent and the definition to wanting to get the agent to just make good decisions. And I feel like when you work with humans and like with people on your team, the best developers that you have on the team, you or even like yourself and your future self on it, it's not so much that you expect them to kind of truly kind of represent these definitions of your software, right? Or sort of, the historical decisions that you've made and that need to bless and all that, but rather that you expect them to combine intelligence and information, to combine, just like smart decision making and kind of conclusion drawing with the right context, using a term that I think is good for humans and agents, to put the emphasis in the right spots. They should know how much you care about finance and budgets versus how much you care about, speed and latency. How much you care about functional programming, versus how much you care about, Ruby, how much you care about security versus, like just sort of all of these different preferences, and even your kind of business surroundings. So it's sort of an understanding of your constraint. And sometimes those constraints may include, it has to be written in this language, right? Maybe if you are building within Microsoft and, someone condones it, well, this has to run on Windows.
Right.
So that's a constraint and that limits some of your options. So I don't know, like I really love and still expect a representation of these things to manifest. But I wonder, where is it that we, even if we're thinking ahead, we're not thinking sufficiently ahead, and we still like the idea of a data model that can represent robustness, right? Or some semblance of determinism, when really it's more about making good decisions.
Yeah, I mean, I guess like just a random thought from what you were talking about is, I think instead of specs, we need to be thinking about building knowledge graphs that, and that sounds like a little bit probably too inflated, but knowledge graphs of all of these things, whether it be the values and variance and intents of the person. Then the beautiful thing with LLMs is they can mine this stuff from you very easily.
Yeah.
They can say, I feel like you're missing this, which is sort of how I did it with the tests I've been doing in this Phoenix architecture so far. Invariants are part of the system, and like metrics of success are part of the system. And you're right that there's like a, I don't know, deploy target or build target or whatever. Like clearly there's still a Windows app sometimes, and there's still a Mac app sometimes. And the way I'm thinking about it is there's probably just like a set of patterns that I'll say I create for myself with this Phoenix thing, but there's, everyone's going to have their own probably center of gravity of ways of doing this that they adhere to. But for mine, it would be a set of patterns that apply to native macOS apps, native iOS apps for now, web apps, TUI apps for consoles or whatever, server-based things, and even, like distributed systems, so that I have an architecture that I compile into, which can include things like platform. Most of the cases for me, I'll be pretty agnostic about platform and language, but then you could have different constraints that you add to the system. Very wavy abstract stuff because we're not there yet. I mean, the other thing was like we're talking about apps that manifest, but maybe there's just a data substrate and apps manifest on the fly. It could be visual or it could be LLMs, whatever, conversation.
Yeah, there's probably still an efficiency element there. So I really like I also I don't want to challenge. I feel either way we need these data structures for it. And there's, I think another lesson learned a little bit is that you can't be too far out into the future. You have to think a little bit about it. And so I think the Phoenix architecture is already fairly dramatically innovative and a bit of a mental switch to embrace, for anybody in the current software development world. So even if it is a stepping stone, as you think ahead, it is very likely to be a kind of necessary stepping stone. I also really like how it enables something else that I think about, which is personalized software. And the idea that, because I find increasingly, I don't know if you feel the same, which is I use a bunch of tools that I really like, and I don't really have a problem with them. I don't want to vibe code an alternative, even if I could. It's good. It's good. I don't mind paying them a little bit, is what I do. But what I increasingly get frustrated is that I can't customize them. Like I want to add, they don't have this feature, and I'm annoyed. And it's almost to the level that I was like, you know what, I'm going to write one of my own just because I want that feature. And I guess I'm imagining a world in which you, the author, can produce a piece of software that has some of these definitions of what you can muck about with and what you cannot. What is the essence of this piece of software, and it has to be embedded. And what is it that, Chad, if you want to sort of add a different UI, a different web app, for this, maybe this is one that we do know we can do because APIs and all that, but you can modify it. And like, have you thought about like the Phoenix architecture or whatever I don't know how to kind of call the whole thing, but like that type of platform being an actual distributable, that this is the software that you're sending off to users?
Yeah, I think so. Although it's not that I disagree, but the way I've been thinking about this is more from the data model up. And it comes from like the local first community, specifically. I think Ink and Switch wrote a good thing called malleable software about some of this. But, like in the local first community, it's all about your data is local, it's on your device. People write applications that interact with that data. And then, you have CRDTs, et cetera, for synchronizing this stuff. So why wouldn't you have like a shared data model across? And I'm answering a question you didn't ask, but imagine you had a shared data model of all the sort of common things you need to do.
Mm-hmm.
And anyone could write software that allows you to interact with your shared data model. So it could be your productivity stuff like meetings and tasks and emails and stuff. If it's not in a cloud and it's not on some private server that you have to deploy to, but rather it's a software that you run locally, then manifesting new interfaces to these things is sort of just like an assumption, because third parties, maybe one company writes software that you start using, let's say Linear, which is actually local first software. Someone else could then come along very easily and write the second interface to that same stuff. And Linear can't stop you. They wouldn't want to, because that's part of the point of doing local first software. And maybe I'm just like an old stupid software developer that's still chasing this idea of reusability and the semantic web and everything. But what if we could now think industry-wide, or at least in pockets of consortia, about like doing local first as a default, and having shared data models by default, schemas, JSON schema, whatever it is, schema.org that is, so that new vibe-coded apps just talk to this stuff and there's an assumption that it's there. I think this is really interesting. The other idea of like constraining which parts are malleable is interesting, although I don't see why there should be a limit to which pieces of the software you should be able to change. Though maybe, from an IT department perspective, I do see it, because, someone calls and says my software doesn't work because I changed it. That's a bad thing.
But part of it is not so much the constraint about what you're allowed and not allowed to change. Like at least a portion of it is just, like if you invested in Wunderlist and you created and you've spent this deep thinking about, choosing the right functionality or visuals or like means of it or the things that will drive the correct kind of to-do list handling. And so I don't want to lose that. I just want to add this feature. So it's more like de-risk me when I add my sort of experts to my own social network button that didn't exist on it because, I wanted to extend it. Can you help me preserve, Chad's brain, when I got the software from you and just modified, I mean, like big software does this, right? Like CRMs and all of those you would customize to your organization. I just find it interesting to think about.
Yeah, it is a great idea because, one of the things that we all, when you start talking about regenerative software, the immediate pushback is you can't just regenerate the whole thing. The users won't know how to use it. So it's true that if you could define even paste layers within the UI, maybe like this panel and this panel or these types of panels are things that are always extensible. It makes sense. And you're right. It's like a lesson from the 90s or 80s or, this has been a thing in enterprise software forever. Usually not because they want to preserve the experience, because the experience is usually not very good, but everyone needs to customize them.
To the constraints. And I love the idea of pace layers. And to be clear, I'm a huge fan of reusability. I think even if you get to the point in which LLMs can create and agents can create everything from scratch with very high reliability, that is so massively inefficient, right? I want to create a to-do app and it needs to build a kernel. I mean, why would it do that? And familiarity between different systems, consistency within enterprise systems, just mutual learnings, right? When there's a bug, I don't want everybody to kind of shave and have all of these problems. So
the efficiency thing is a really interesting one. I was talking a couple of weeks ago with one of the founders of Radical, which is this open distributed GitHub sort of replacement. He is now working on something called Radiant Computer. And it's like a ground up operating system that he's building. And he's thinking obviously a lot about LLMs. And he wrote a piece about how you can sort of reduce the surface area of how you interact with something, let's say an operating system, to the benefit of efficiency of LLM use. Because part of what he's doing is everything is private by default and you can run local models, et cetera. Of course, you're dealing with local power constraints and the fact that the models aren't quite as good as the frontier models. And it's an obvious thing to reach, but somehow there's this beauty in the insight that if you you start with an open playing field and then you create this constrained language that actually expresses what the system's supposed to do. And I think this is a version of what you're talking about. Then it becomes a very easy thing for the LLMs to interact with it. And you can do this over time with every system where it starts with this open field and then it becomes, it congeals. Maybe this is what programming languages are in the future. You asked, about new programming languages. I don't know. There's another guy, Guy Steele, who is, I'm sure you know of him. He's a well-known programming language researcher. He did an amazing talk at UPSLA in 98, I think, called Growing a Language, that every generation I reintroduce it to people because it's always relevant somehow. But the talk starts with him defining a subset of English from scratch that he can use for the talk. And it's all this big lesson on building up vocabulary and building up foundations so that you can then be expressive. And maybe that's what we end up evolving toward, because in this agent, this rapid change, rapid software creation environment, we should be able to create tons of reusable vocabulary like this.
Yeah.
And we should be able to easily differentiate between what's reusable for me, what's reusable for my organization, and what's reusable for the world. And the ideal state is that we figure out markets for this or ways of sharing this stuff.
Yeah, no, absolutely. And we've gone through all of that type of thinking as well at Tessel in the early days. It's he create an HTML to Markdown converter for me. Sounds like a simple spec. Which HTML do you mean? Which Markdown do you mean? On it, to be loaded in a browser. Which browser?
Right.
So and these things rot over time, right? Whatever, if you interpreted today's LLMs will interpret the thing from 2 years ago. Well, I guess actually maybe it stays the same because it's persisting itself. But over time, the definition, in 5 years.
Hey everyone, hope you're enjoying the episode so far. Our team is working really hard behind the scenes to bring you the best guests so we can have the most informative conversations about agentic development. Whether that's talking about the latest tools, the most efficient workflows, or defining best practices. But for whatever reason, many of you have yet to subscribe to the channel. If you're enjoying the podcast and want us to continue to bring you the very best content, please do us a favor and hit that subscribe button. It really does make a difference and lets us continue to improve the quality of our guests and build an even better product for you. All right, back to the episode.
So I want to ask you though about another set of posts that you have there. There's more about evaluations and durability. And so if everything is regenerated, and as we've been talking here, there's some that's not always ideal, and there's some accumulation of learnings and preferences and distributions. You have a statement that said evaluations are the real code base. They are in one of these posts. I guess how do you think about durability? What is it that as I build IP or as I build up anything, persists across?
Yeah. Yeah, so I do say this thing about evaluations, and it might be an overloaded word where it sounds like I'm talking about some like modern definition of evaluations in the context of LLMs or ML, and I'm not, although I also am. I'm really talking about invariance, metrics, constraints, all these things that we were just talking about, like to take a stupid example, just because it'll be easy to talk about. Let's say you have, an order record in a database, and you're just talking about like the CRUD operations for orders in a e-commerce system. There would be like correctness requirements. Obviously, there might be side effects that you expect when an order is placed that should also happen, so that you can like measure the fact that happens. There might be speed constraints, there might be memory constraints or IO, or all these sort of like system level things. And to me, like this set of stuff, and this is kind of why I was talking about knowledge graph earlier versus specs, because I think you have to create this knowledge graph, which may be pretty inscrutable, that we probably need tools for dealing with this too.
Mm-hmm.
But it captures all this intent. It's both business intent and technical intent. Now, in my old naive way of doing things, which is still the way I would do it for now, like I would always talk to my teams about focusing on mean time to resolution of problems versus mean time between failure, which was another way of saying, like, don't worry so much about testing everything up front, but let's just make sure everything is really well instrumented so that we can easily roll back. And so like my way of changing software is YOLO in production, just to sort of overstate the point.
Yeah.
And then immediately respond to the live metrics and the real state of the system via intense observability at all layers, including business and technical. I think there's probably some aspect of that still,
right,
at least for now, in a system that's going to be changing rapidly like this. The other thing is you can create tests, and you can do it both before and after the fact. And you can do it really rapidly with AI now. So I think there's a thing where, and you were talking about like locked tests, I think, in your way of thinking.
Otherwise you don't know what to trust, right? You take some spec, you create code, you create tests, they disagree. Who's right?
Exactly. Yeah. My way of thinking about it right now is there's like at least a layer of tests that like everything is locked. There isn't a differentiation between locked and not locked. Of course, I'm not writing tests anymore. I'm not writing any of the code, but so I'm explicitly talking to the agents about the purpose of the tests. And the purpose of the tests is based on our current understanding of the system, like in my IRC system, for example. I will go through runs where I have it just like look for all of the possible edge cases we might not have thought of for a certain class of bugs. And I get multiple models, multiple times to do this. And then I review it and I have it create tests that discover bugs. And then I have it work until the tests run all the time. And I keep this layer locked all the time. So that's sort of like the way I'm thinking about evaluations now. I think probably it goes further and further when we can collectively spend more time on specs to canonicalized requirements to invariants and this sort of
Yeah.
chain, because that gives you something different to reason about in a more automated way. But right now, I think just this sort of metrics plus tests is the way to go.
I'm a big believer in evaluations. I think in the like first year, if you will, of TESOL, I was thinking a lot about tests as the things that persist. And you'll have tests, you will log tests. This is the behavior of the functionality. Increasingly, in my current worldview, I think more about making good decisions. And so the tests that I want are more the tests of my agent's behavior as opposed to the tests of the system that has been built. And those are, I don't know if you'd call anything classic these days, right? But those are AI evaluations of saying, hey, is the agent behaving as I am? And I guess I perceive that to be a higher leverage point because you're making the developer that you want versus making the system that you want. And the developer that you want is actually much more powerful than a system because they can create the system that you want at a fairly high fidelity. And what's interesting is the same concept that you said right now is true though. Like there's still an element of you have to capture and aggregate what are the evaluations that represent what you want, and you probably have to accumulate them. And over time you need to curate them, which is still like we don't know how to deal with that yet. We have to think, but at least evaluations speak in slightly higher level terms of like when this happens, that like the behavior. The developer behaves like this, but still a volume challenge of how many of those do you assess. But then once you get that, the instructions, the specs actually are malleable themselves because they are. They also change with the models, right? Like the way that you would instruct Haiku is different, effectively, is different than the way you would instruct Opus. And we see already that, Opus is very creative, but it's a bit of a smartass and it doesn't follow instructions. And, Codex is less creative, but it is more obedient, in that sense. And, Gemini has its own traits, and just each of these things is different. And so when you think about these, again, if you really continue down the same rabbit hole and you continue, you move from programming languages to programmer language, right? It's the language with which you instruct the agent versus the language with which you define the system.
That's really an interesting approach. And I feel this, like I switched from Opus to another model trying to arbitrage credits a week ago. And I had a very frustrating day until I woke up the next morning and realized, oh, I changed the model. That's why it feels like, 2025 again. I blamed the model. I probably should blame myself in the way I interact with the model. However, that actually sort of makes a point. Like when you said, try and make the best programmer, I think this is a really cool approach. And it's absolutely the opposite of the way I think about it. I just assume the programmers are both idiots now and going to be geniuses later, and they're going to progress at different paces depending on the model. And so I lean toward trying to create a system of code generation. Maybe that's the programmer, I don't know, but it's not an intelligence, but a system that allows me to plug in the most idiotic LLM here and the genius here and still have some results that I feel I can trust, but also decouples me from thinking about the models underneath. They're just going to keep changing and getting better. Of course, eventually, all this stuff that we're talking about is going to be irrelevant too and obsolete because the models are just going to.
There's a different point in the future, which is, having kind of a more intelligent conversation by a couple of AI models than what we're sort of having here. But and I think for what it's worth, I think you need both, because I think amidst the team, you need some form of definition of the output of that, intelligent programmer that captures the definition of your system and makes it easier for the programmer to be, less intelligent, or even just to capture the alignment on what the system does, and making that increasingly LLM friendly, so it's easy for them to understand and kind of apply and represent instructions. And then you separately need the instructions of the developer. And I think, to me, context engineering is about that, right? And I think we started writing, and we'll probably talk more about the context development lifecycle. And I think the agents will handle the software development lifecycle, and we need developers to sit in the context development lifecycle as we develop context. And the context really is the operator's manual, right? It is about how should the agents behave, and what are your intents. It'll be interesting to see the interplay there.
Yeah, a friend of mine, Jess Martin, is working on something called Context Library, which is a way of automating building up context of all of these decisions that you make,
Yeah,
with the goal being kind of like what you're saying, run agents all night while you're asleep, and they make decisions based on probably what you would have said because they have enough context in the system
right.
built up in
Yeah,
a way that's usable by them.
yeah. I see a lot of that, and then I do wonder. The reason I say context development, I think it's a different view on it. Although time will tell which one is right. Which is there's the spontaneous, observe me and understand what I do. But then what I do today is not the same as I would have done a year ago, and let alone 10 years ago. And so, like the alternate approach is context is the thing you develop. It is not a point in time. And we all know, like, at one point during the LLM kind of iterations, all the rage was learn my code base. And then we learned, it's like, there's a bunch of stuff in my code base that I do not want replicated. In fact,
Yeah.
most of the stuff in my code base I do not want replicated because it's been accumulating garbage and garbage in, garbage out. And so it's not that it's not useful, but you want to develop your sort of practice. So it's interesting. I guess maybe it's a good point to sort of try and conclude the conversation in the point of timeline. So what is your thesis? Like, you're building, put aside sort of the guide to the programmer even side, the switch from current day software to immutable, regenerative, Phoenix architecture style software. Like, what do you think is a practical, or what is your anticipation in terms of the kind of the path of adoption for software actually changing to be working like this in the industry?
I think it will be both really quick and incredibly slow. And the slow part is the realization we need to all make that we have systems that have been in development for decades and no one understands them. And most of us nerds out on the frontier are not thinking about them so much yet. I think some of us are starting to. So like, I think, if I were to go start a company now, I would be doing the company this way today. So, greenfield code base right now. Now is the answer. And I know some people who are doing this to, varying degrees. But I also know of development shops in, fairly forward-leaning companies that are barely touching AI at all, and they're resistant. And there's a huge portion of the developer population that's afraid or just not
Mhm.
paying attention. Just like when Java happened, they didn't want to do Java. They didn't want to do Ruby and Python, they just want to have fun and go to work as little as they can. That is the truth about most people in their jobs, which is fine. That's, humans are humans.
Mhm.
But organizations are backward, organizations are slow. Most people don't know how to deal with this, and they're going to be looking at like large consulting companies to try and figure it out. So I think it's a long, long time before there's a mass adoption of AI generated software up and down the stack through, the largest enterprises. But there's a lot of interesting work that should be happening probably in the coming year or two, because so many of us and companies I'm talking to, from my perspective as a VC, are having these same conversations about like trying to capture intent and what is a spec versus intent and where can intent come from. You could mine it from corporate email systems for the last several decades. You've got all that stuff captured. You could mine it from source control system, project management. So work being done to figure out the legacy intent of a legacy system so that you can then start automating maybe like strangler fig pattern, breaking pieces of an application off. But yeah, I think it's going to be like insanely fast on one side and surprisingly slow on the other
On the
side.
other, yeah. I think that's a good, it's almost always like the right answer to like any diffusion of technology. One of the things that I do feel, and maybe this is in sort of Tessel on the company building ethos side, is that one of the reasons that we've kind of focused on this sort of, train the developer versus, define the system in the offering. There's a whole bunch of reasons. Some of this stuff needs to, be open source, needs to sort of be part of the agents. There's a variety of reasons. But part of it is that if you train the programmer, then you're sort of simulating the human behaviors, right? Like, in these ancient systems that are so fragile, there are still humans. They're operating in there and they're making decisions. And those decisions are, by and large, these companies are still alive, right? Like they are growing, they're modifying it. And so there's some logic by which they are making this work. And so it felt like it's, even though conceptually, as we talk about, it's a higher layer and it's maybe a further future to think about training the programmer versus training there's actually, in some aspects of it, a more short-term applicability of it.
Yeah.
Because that better programmer can help you do better on the systems, even if it doesn't fix the fragility or it doesn't make those systems, be able to rise up from the ashes.
Yeah, I agree. I mean, I think, it's like what I said about everything's going to be obsolete that we're talking about at some point. I think there are waves where we will solve these problems in the way we're talking about today, and it's totally valid and it will be useful for a long time. But the industry is just going to go so fast, we'll think, oh God, what we're talking about now is silly, but it's still useful, but it's maybe not the future anymore, The
Yeah.
beautiful thing about today is we can go so fast, we can deal with all these different phases, and we can have roadmaps for our companies where we just say, okay, we'll get to that when it's a problem. Okay, now it's a problem, boom. Next week, we've got a whole new release, It's like a miraculous time to be a software developer, as well as a terrifying one. But yeah, I think we get to be like steering through this crazy time. It's really exciting.
Yeah, definitely sort of fasten your seatbelt, but it is an exhilarating ride. Chad, this has been super, super fun, fascinating, future looking, sort of deep on it, and I think right in many ways. So I'm really looking forward to the open source version of it and to hear more about this development. I don't know if you want to say if people are keen to find you, to invest in their sort of invention of sort of future of software development, where can they find you?
Probably Blue Sky is the best place. I'm chadfowler.com on Blue Sky.
Sounds good. So thanks again for coming onto the show.
Thank you. Very fun.
Thanks everyone for tuning in, and I hope you join us for the next one.